So we're going to use a graphing program today, and this is how you open it. Sometimes it'll be at the bottom. In your toolbar, you just click on it, and that will open it up. It's that green one called Excel. Okay, you can also open it up using your Spotlight. So you just type it in, Excel, and then you'll find it, click on it, and it'll open this thing called Microsoft Excel. We're using Microsoft Excel today. You can also find it by clicking here, going under Applications, going all the way down to Microsoft, and then you'll find Microsoft Excel. So it's like 3 different ways to open your program. And that's the program we're going to use to graph today. We're going to learn how to graph. Okay, so we're going to start graphing. I'll describe an experiment in a bit, and we'll graph it. Okay, gang, so we're going to graph an experiment. We don't have time to always do the experiments. You guys did something with a pendulum, so we don't have time to do this lab in particular. It would have been nice, but I'll describe it to you. And it's going to be a cause and effect type of lab. There's going to be 2 variables graphed against each other, x and y. What's usually graphed on the x-axis is what we call the independent variable, or the cause. And so right now we're going to cause an effect by adding mass to a spring. So the more and more mass that we add to the spring, the more and more the spring will be affected by changing its length or stretching. So how much mass we put on there is in grams, and we can control and decide exactly how much mass we want. And we know what that will be. So that's the independent variable, or the variable of choice by the experimenter, or us. The effect is going to be how much the spring stretches. That depends on the spring, if it's a different spring, the characteristics of the spring. So this is the effect, okay? And we call this the dependent variable because the stretch depends on how much mass we put there, right? The mass is the cause, and how much centimeters is stretched is the effect, okay? So the mass will be graphed on the x-axis, the cause on the x, and the stretch on the y, the effect, okay? So independent variables on the x, and I know even though it said stretch was x, I'm sorry that's confusing, but they're reusing the letter x, so sorry about that. But yeah, the cause is always on the x-axis, or the independent variable. So what I have here, right, is the cause, the mass. And right now we have it in weight in pounds and stretch in inches. So this is not something that you're necessarily going to have to worry about, but it's showing a little conversion where I converted weight to mass and inches to centimeters. And so I did that on my own because I got this table from the internet. And I'm changing so that we have at least 2 sig figs. So I'm putting 1 decimal place. I'm kind of changing. What you do is you press Command 1. Now this, guys, is a program called Excel. And so if you just spotlight it and find it, Excel, it should be fine. I'll put a little video clip at the beginning of this video, and I'll do some audio for that to show you how to open up Excel. Basically, you'll have a data table just like this, and you'll just type it in. Right now I'm going to cut and paste, but you can just type things into these grids. So these little cells, you can type things in. So hopefully that's not too much trouble. We'll probably do a little bit of live lessons about how to set you up for this. But this is how you take your data and graph it. That's what this video is all about. So Excel always goes X on the left axis and Y on the right, column. So whatever you want on your x-axis, you got to put that on the left side. Okay, and on the left side is always an independent variable for whatever scientific lab you do. And Y will always be the dependent variable. It's always in the second column for using the Excel spreadsheet program. Okay, so the independent side, that's going to be the cause, which was what our mass, right? The mass was going to cause stretch or length, a greater length in the spring. Okay, so that was the cause and effect. And so since the cause was the mass, that's going to be the 181 to 800, right? Yes, that's fine. That belongs in the X. So we're going to paste that up there. I think we're going to make sure that it's I think what I wanted to do is cut and paste, not copy and paste, to make sure I got all the data. So I did fumble a bit here. You're going to actually type in the values. You'll see it on another screen and you'll just type it in. Okay. And usually the independent variable is, the left side is displayed on the left side, but sometimes it's not. You have to pay attention. It's not always going to be that way. But hopefully we'll try to make it simple for our first assignment, etc. So independent is the cause, and dependent is the effect. Okay. I think I might be punching in here. Yeah, I'm double checking all of that. And as long as everything's set up correctly, you'll be okay. I don't know if I'm typing in a 0 here or not. Oh, yes, that's what I'm typing in. You should say what you're actually, because we just said cause and effect, right? We didn't even say what the specific lab was. So all those numbers in the left column is mass, and those are all in grams, so 818.2 grams at the bottom, and stretch in centimeters. So the maximum length that we had in our experiment was a stretch of about 11.4 centimeters. So your data table should, say what you're measuring, mass in grams, and stretch in centimeters. So now what we do is that, notice that we go to chart. So this was touchy. We had to go to insert, and in the insert menu, the tab at the top. And then we went to, so hopefully you got to rewind if you're having trouble, but the scatter plot's right there. It's the bottom middle. And you just click on it. If you've highlighted your two columns, then it'll be fine. See, notice how the columns are highlighted on the left, and then you went to the insert button. Now we have to have chart titles and axes titles. So you can just go ahead and click on it and you'll be able to type it in. It's always y versus x. So whatever we're measuring on the y is what we say. So that's stretch, and the x was mass. So stretch versus mass is an appropriate chart or graph title. Now we're also going to go to add chart elements. It's up there in the upper left. And we're going to do axes titles. So the horizontal one, right? What's the horizontal or x-axis? That was mass in grams. That was the cause or independent variable. And then after that we have the y variable. So go upper left. There you go. It's plain as day. You can rewind. Is going to be your dependent variable, which is stretch in centimeters. And I guess I wanted to capitalize the S in stretch. Okay. So don't forget, you need to have your units, and you need to have your axes labeled about what it is a measurement of. Otherwise, it's just meaningless numbers, and your graph could be anything. So we're going to assume that this came out kind of linear, but nothing's perfect. Okay. What we're going to do now is add our best fit line, our trend line. You have to click on a point. It's important to click on a point. Okay. If you don't click on the point, then this thing can't create the trend line. So click on a point. So I repeated that 3 times because if you don't do that, it won't do your trend line and you'll be frustrated with what's going on. Okay. So if you click on it and it's highlighted like that, each of the points has that little kind of X mark on it. Right? Now it doesn't. Oh, now it does. Make sure it's on there. Okay. And we're going to go, oh, I see. And if you ever lose your way, okay, what you want to do is go to chart design. Chart design right there. Okay. Right side. And from there, you can go to add chart element again. Because we're doing add chart element, right? We had our axes titles. But we're going to go to trend line now. We're going to go to trend line options at the bottom. Okay. Linear, right? We want a best fit line. Here's another important factor. We want to set the intercept to 0. A lot of times, well, anyway, that's the way that I like to do it. Could be different for your teacher. But the equation is going to be displayed on the chart because we simply click the button. So there we have it, y equals mx or y equals slope times x. You notice that our data goes through 0, 0, so if there was no mass, then it wouldn't stretch. So that kind of makes sense. It should be something that's there. It's definitely a data point that would be valid. And then that 0.0129 is like the slope, right? So the easiest way to think about it is like if I had an x of 1,000, then I would have a y of about 12, right? Or 12.9. So if I had an x of 1,000, then I should have 13. And you can see, oh yeah, if I extrapolate, it would be about 13 if I had 1,000. So, and that would correspond to that slope of 0.0129. And that's how we graph, guys. So watch that as many times as you need to help you create your graph for your assignment and also later your test.